All right. So now here we're gonna do the questions. As much as we've started with the basics, so it's very important to also do the questions, not just only the basics, to see how these questions are being asked and how to tackle these questions. And then I'll also try to add some basics here and there where I can, based off on these questions. So now let us start without wasting any time. We're gonna start reading question where we're gonna start here at question number 6. Question number 6, they say to us, in the diagram below, we are given two graphs. We are given the graph of F. We are also given the graph of G. And the graph of F is tan graph. And then the graph of G is cosine graph, drawn where X is the element within this interval between negative 90 degrees and 180 degrees. We are not also given the equations, we are also given the sketches of the graphs. So most of the times they will give you the equations and they would expect you to draw the graph. Sometimes they will give you the graphs and then they would expect you to know how to determine the equations or the bits of the equations. They will give you the unknowns there and ask you to determine the value of A, the value of Q, the value of B, and so forth. So in this case, everything it is done for us. We just need to be good at interpreting the graphs and knowing what are the combination of these basics all about. So now, 6.1 says to us, write down the period of G. If you remember when we were doing the basics, I have tried to tell you what is the period all about. Now, to determine the period of G, you go to your equations and then you go to your sketch. You're going to look for G. Now, this is the equation for G, meaning the cosine graph. And then you go to your sketch, and then this will be the equation for G. It's a cosine graph. We can see it. As much as I've taught you to do, as much as I've taught you to always look at what matter graphs actually looks like, it's very helpful and it will make your understanding much more better while you refer to your matter function. Ne? If you remember, I spoke about the matter graph or the matter function. I said to you, the matter function, it is a graph that actually looks like this. Look, what I'm doing right here, you don't have to do it, but you can do it if you really want to understand what you are actually doing. You understand? I said for cosine graph, the matter graph starts like this, and it moves like this. This is the matter graph. And I say the period of the matter graph is between 0 degrees and 360 degrees, right? Meaning this graph, it can continue, but by just looking at this, why am I saying the period is between 0 and 360 degrees? Because we are talking about a complete cycle of this wave. This is a wave. This is one wave. So this is one complete period. So meaning if I decide to continue with my function on this side of the Cartesian plane, therefore my cosine function will actually look like this. Now I have two waves. So from 0 to negative 360 degrees, I have two circles, right? Remember, I showed you how do I mean when I say these are two circles. This cup over here, it's this one. And then this half over here, it is this one. And then this half over here, it's going to be this one. It makes one complete revolution, which is 360 degrees, if you still remember. Sharp, fine. So we are not too much on the basic here. We want to solve the questions. But I want to relate you to this basic and this question over here. So, okay, if we have two waves just like this, right? From what did I do here? I sketched a graph of a cosine, right? And it's a matter function. And then the interval at which I sketched this graph, I'm going to say it is between where? It's between 360 degrees. However, I can do my interval however I want to do. Okay, let me do it like this. let me do it like this, like how they did it there. When I say x is the element of negative 360 degrees to positive 360 degrees. This is how I sketch this graph within this interval between negative 360 to 360. So when they ask me to determine the period of this graph, remember what did I say to you? Based off, I don't have the equation. Did I draw the equation for this graph? No. So that means I have a sketch of this graph. So how can I use the sketch to determine the period? I'm going to look at the points that are in phase. This point and this point, it is in phase. So that means from here to that point, I'm talking about one wavelength or one complete cycle of a wave. So that means because I'm talking about a complete wavelength over here, I'm talking about one wave. So meaning the interval where I find these 2 points that are in phase, which is between 0 degrees and 360 degrees. Therefore, this is the period of this function over here. So that means I can determine the period by just looking at the graph, right? And therefore, because this graph, having a look at it, it's a matter graph. So let me just call it f. So f of x of this graph will be equals to cos x. So again, if I want to use the equation to determine the period, I'm going to look at the coefficient of x in this trig function. So the coefficient of x here is cos x, meaning it's cos 1x. So to determine the period using the equation, I'm going to use the period divider. In this case, remember for cosine, I said we'll always have 360 degrees divided by the coefficient of x, which is 1. So that means I will get 360 degrees. So there are two ways to determine the period of the graph. It's either you use the equation. By using this equation, period is equals to 360 divided by the coefficient of x. Remember, I said this is b. You can say 360 divided by b. But in this case, our b is equals to 1. So that's why I'm dividing by 1. I get 360. Or you can just analyze your graph. Look at the points that are in phase because this is a wave. So you're looking at this point at that point. So they are within which interval between 0 and 360. So that means the period is 360, even by just looking at this side. This point and this point, they are in phase. So it's between 0 and 360 degrees. So the period of this wavelength is 360 degrees, right? Sure, that's how we look at the period. But now look at this graph, right? This is another graph. But the question is, what if our graph looks like this? What if now our graph looks like this? Draw my Cartesian plane there. What if my graph now looks like this? Instead of me starting from this point, just like here, instead of me starting from this point, moving downwards, just like this one. So what if my graph starts like this? I can consider this as a matter function, but it's a matter function that has reflected about the x-axis. So that means this graph over here, I'll call it g of x. So this graph over here will look like this, will be negative cos x. It is the same as matter function, just that we have the negative there. So it's a reflection about the x-axis. You see, this graph and this graph are exactly the same. The problem is we just multiply the values of y by negative. You see here we have negative and then there we have the positive. So we multiply the values of y by negative. It is a reflection about the x-axis. This is one of the basics that is highly related to the functions. You understand? So that means it's just a reflection about the x-axis. So now, how determining the period, this does not matter. The reflection about the x-axis, it really does not matter. We still look at the coefficient of x if we want to use the equation, or we look here it's between 0 degrees and 360 degrees. We are talking about the period of the function being 360 degrees. So it really does not matter how do we go about for that, okay? All right. Just wanted to touch on this one. I remember I never showed you the reflection about the x-axis, but this is just how reflection, because now me looking at this graph over here, I can see we have negative. You see this negative amplitude over here because it means it's a reflection about, that's why it starts here. Normally we would expect it to start here and move like this. But the problem is because it starts here, it is because of that negative over there. Okay. All right. Or you can also look at it from here. You see, there are many ways to look at these things. You can also look at it from here. From here, see, it is still fine. It's fine. So let me erase everything then. So now, to answer this question, which is 6.1, they want us to write down the period of the function, right? So how are you going to write the period of this function? I said there are two ways for you to determine the period of a function. It's either you use the graph, I repeat, it's either you use the graph or you use the equation, okay, to determine the period. It's all up to you because they just say write down. It's 1 mark. So to answer this question over here, okay, let me come here. To answer this question over here, which will be question number 6. This is 6.1. So to answer that one over there, we're going to say our period of G, let's look at it. We can use the period divider because it's cos. So we know but again, we're gonna have 360 divided by 2 to look for period because the coefficient of x is 2 and therefore we're going to get 180 degrees. So that means for answer here, 6.1, we're going to have 180 degrees. That will be our period. If you don't want to look at it from the equation, you can analyze it from the graph. If you are really that good, look at the points that are in phase. This point and this point, they are in phase. So this is one wavelength of a cosine function. Remember the graph of G, this is the graph of G. So looking at this point and this point is from 0 to 180 degrees. We have one complete wavelength within 180 degrees. So we can just also look at it like that. Or we can look at it like this. We can use these points, okay? There are many ways, you see, so that means you can't get this one wrong. This point and this point, they are in phase, right? This is one wavelength. This is one complete wavelength between negative 90 and 90. What's the distance between? This is 90 plus another 90, you get 180 degrees. You can also look at it like that, looking at the points that are in phase, not out of phase. Grade 10 physical sciences, you see? All right. So that's how we go about for 6.1. I gave you many ways to kill 6.1, right? So it's up to you which one to use. Now we move to 6.2 where it says to us, determine the range of g of x. When you talk about the range, we are talking about the y values for graph of g. Now, what I'm going to do is I'm going to the graph of G, which is this one over here. We can see it, the graph of G, which is this one over there, the cosine one. So we want the range. I'm saying to you, we are looking at the Y values. So when we want to determine the range, what are we talking about? The range simply means where does the graph ranges from, where does the graph ranges in terms of Y values? Of Y values, ne? Just like the domain and range are the exact same thing. It's just that domain, we are looking at the X values. Meaning, I want to use a word range because I believe we are all familiar and understanding of what does the range mean. Range meaning between the maximum and the minimum, right? That's the range. Like, what's the salary of people who are working at the salon? Maybe they're not earning the same amount. So you're going to give me a range. They earn between 2,000 rand and 5,000 rand. They range between there. That's the maximum and the minimum. So in terms of when you talk about the range, we are looking at the Y values. When we are talking about the domain, we are looking at the X values. It is the same as range. Basically, what I'm doing, I'm teaching you the trig functions and I'm teaching you the functions that with linear, hyperbolic is the same basic, by the way, okay? So when you talk about the range, look at this graph. Look at this graph. You see how it moves. Look at this graph. Look at this graph. Look at this graph. It's moving along the x-axis. At the same time, it's moving up. You see, it's moving along and down. It's moving along the y-axis. So look at me. In terms of y values, this graph, its maximum, it's here, right? Its minimum, it's here. This is the maximum. This is the minimum, right? This is the max because it's positive values. This is the mean. It's meaning it ranges. It ranges where this graph in terms of y values, it ranges between here it's gonna be half. If you look at it, ne? It's gonna be 0.5 and negative 0.5. Here we have 1, and then there we have 1, what's this? Positive 0.5, and then here we have negative 0.5. If you look at it like this, or you can say 1/2 and negative 1/2. It ranges within this y values. Can you see that? Probably you don't see it. Let me rephrase that once more again. When we are looking at the range, we are looking at the y values, right? Where does our graph ranges in terms of y values? So I'm saying to you, look, here, our y value, it's 0.5, but this is our maximum. How do I even see, okay, this is 0.5? By just looking at the amplitude. Remember, this is the mother graph. It did not shift up or it did not shift to the left or right. So it's fine to say my amplitude will move from here to here. Or if you forgot, you can say your maximum minus your minimum. But in this case, we don't know our maximum. We need to figure it all out, right? So meaning here, over here, this is our maximum, and then here, this is our minimum. So look, these are the y values, right? Even this one, it is the y value. So our graph plays along between those two lines. Here we have 0.5, and then there we have negative 0.5. Or you can say you have 1/2, or you have negative 1/2, which also defined by our amplitude, which is from there to there. It's our amplitude to 0.5. Can you see that? So to determine the range of g of x, how are we going to write that? The range of g of x for 6.2. So for 6.2, we are actually going to say the range of g of x. Let me see, 6.2, right? It's going to be what? It's going to be twin included, you see, because our graph, it also passes there at 0.5 or 1/2. We're going to include that. So when you use the inequality signs, we have to include use the one that I include. So we're going to say y, because we're looking for the range. We're going to say y, it is less than what? Let me do this. We're going to say y, it is less than what? You see, remember, it is less than positive 1/2 because we are going down. It's less than, it's gonna be less or equals to 1/2, but greater than or equals to, you see, why am I saying greater or equals to? Because I am including that 1/2. Equals to means I'm including it. But if I had y less than 1/2, so that means I didn't include 1/2. But immediately when I say equals to, therefore I am including 2. Because our graph, indeed, it is passing there. That's not an asymptote, right? That's why I'm saying I'm including it. So y, it is less than or equals to 1/2, but greater than or equals to negative 1/2, which is true because we can see here we're being greater, right? From negative 1/2 to 0 to 1. That's being greater. We are increasing. So our range will be between this interval. Or if you don't want to use this notation, you can use a set builder notation. You can say y is the element of square brackets means include, right? Between negative 1/2 to positive 1/2 include. We are including 1/2 and negative 1/2 because our graph passes there. Do not use the round bracket. Use the square bracket. Okay, that's how you can do it, like this or like that. So showed you 2 ways to kill a bird. Most definitely, we jump to 6.3. Let me erase this so that we don't confuse ourselves. So now we're gonna jump to 6.3. Now, how does the 6.3 goes about? 6.3, it says to us, okay, let me just leave that note there. 6.3 says to us, use the graphs to determine graphically the values of x. We want the values of x under what condition? Look, your answer here is supposed to be x is equals to 2, or x is greater than this, or x is between this. We are looking for values of x. Under what conditions? Under these three conditions. Under these three conditions. Under these three conditions, right? Under these three conditions. Now, the first condition, which is 6.3.1, 6.3.1, right? When f of x is greater or equals to 0. So you go to your graph. They say use the graph. Do not calculate whatever. Do not take the equation of f and then say greater equals to 0 and solve for x. Yes, it's true. We are looking for values of x. Whether the value is going to be one value or many values, it does not matter. That's what we are looking for. So we are using the graphs. It's very important for your analytical skill to be on point at this point in time. Even the functions, the one that we passed, hyperbolics, linear, parabola, exponential, guys, these basics are the same. What I'm doing here is the same as me doing those functions. So let's see then. So we want where f of x, we want where f of x is greater or equals to 0. We are including 0, that means. So let's go for, this is the graph of f, right? Number 1. You see where I'm highlighting? Already, f is greater than 0, meaning f is above 0, because you see this line over here. This is where 0 it is at. And then f means the y greater or equals to 0. Remember, f of x, this is the same as y. If you remember, this is the same as y value. So my y value is 0, my y value is 1, my y value is 2. So I want where my y value is above 0. It's going to be this side. It's going to be this side, right? Where my y is greater than 0. My y less than 0 is going to be this side. Can you see the difference? You need to see it. You need to know it. You are analyzing the graphs here, right? So, sharp fine. So, this portion, starting from here, my y is 0, meaning my y, it is including 0, or f at x, it is equals to 0 here, where my y value is 0. Immediately when I go up, therefore, my f of x becomes greater than 0, it's above 0, right? This is where we are actually looking at. And then there is no, here, this is out. This is also out because it's below 0. It is not greater than 0. It is less than 0. So the question was, use the graphs to determine graphically the values of x, where f is above 0. So what's the value of x here? What's the value of x? Look at the values of x. It's here. It's 45 degrees and greater than 45 degrees, because you see, the more this graph moves like this, our x values, they move along in this direction, approaching 90 degrees, approaching this asymptote over here. So meaning we're going to say it is whereby x, it is greater than 45 degrees, but x, it is less than 90 degrees, meaning it's between 45 and 90 degrees. So meaning we're going to say it is whereby x, it is less than 90 degrees, but greater than or equals to 45 degrees. Right? Look. Here, where is 45? It's between. And then pay attention on how I wrote my final answer. Here, I used the inequality sign that includes. Here, I use the inequality sign that do not include 90 degrees. Why? Because 90 degrees, it is our asymptote to start with. So our graph our graph, it won't really touch the asymptote. Look, our graph, it won't really touch an asymptote. See, let me erase this first. Our graph won't really touch an asymptote. We're just approaching it. We're just approaching it, right? We're not going to touch it. So it's between here and there, where you see x is greater than, this graph is greater than or equals to 0. It's greater than 0, moving like this. And then we want the x value. So the x value is going to be between 45 and 90 degrees. So that's the answer for that. And therefore, we move to 6.3.2, whereby it says to us, we want 6.3.2, f at x multiplied by g at x is greater than 0. People think this is difficult. It's not. Look, f at x multiplied by g at x greater than 0. Meaning, what does that mean? That means if you take this graph of f, you multiply it, graph of f multiply by graph of g, you get positive, because greater than 0 means positive, right? That's what it means, okay? So let's go to our graph. I'm sorry. So this is what we are looking for. Look, we want f multiplied by g, we get positive, greater than 0. Where do we get positive, which is greater than 0? Obvious, when you take f where it's negative, and you take g where it's negative, you're going to get positive. Simple, right? When you take f where it's positive, and then you take both g at the same time where it is also positive, you're going to get positive. So these are the conditions that we need to look for on the graph so that we can get positive and positive. Maybe you don't understand what I'm saying, but make sure that it makes sense as I will be explaining it through the graph. Here, I'm just showing you how to get this positive. This positive, it's either positive multiplied by positive or negative multiplied by negative. That's the only way to get positive. You cannot take the graph of f where it's negative, you multiply it with graph of g where it's positive and expect to get the positive. No. Negative by positive, you're going to get negative, right? It's just a simple understanding. Sharp, fine. So our point here is to look where f is multiplied with g to get positive, right? But I'll show you. You don't just look in J. This graph, like you, it's very important how you look at it. Look at this, like, look at it like this. I want f and g at the same time, where they move together at the same time. You can start anywhere as long as you're gonna find all of the solutions. Normally, I start at intersection, ne? I start at the intersection. Oh, I don't like this color. It's not clear. Let me change it. Normally, I start at the intersection, ne? I move to the right and I move to the left. So let's firstly move to the left. If this graph moves like this to here, and then this graph moves like this to here, make sure that they move together, they end together. Ne? That's the first way. And then where else do they continue to move together? It's going to be here. Starting from here to there, they move together. Here, they move together. Where else do they move together? Let's go. They move together here. This is above, it ends there. This is below, it ends here. Make sure that they move together. They approach asymptote together here. But this one, okay, sure, fine. Again, where else do they move together? Let's see, they move together here after this line. Here they are here and till here because this is below. I end here because this is below. Here. See, it's below. But because there it's above, I'm gonna have to do another one, which is this and this. By the way, what I'm doing because I'm teaching you. You don't have to do this in exam. You'll master this the more you practice and as much as you understand. Right, so now we are set. Right. Look at the blue part, this part. This is graph of G. This is graph of F. They are both negative because they are below 0 degrees. They are both negative. So meaning here I have negative G, and then here I have negative F. That means negative F multiplied by negative G, I'm going to get positive. So that means this is our solution. That's the first solution. The blue part, it is our solution. Correct. And then we move to the green part. Look at the green part. G here on the green part, it is positive because it's above 0 degree. It's above 0. It's positive, right? From here to here, it's positive. And then F here, it's negative. Here, it's negative. So we cannot say it's negative. We cannot say F negative multiplied by positive, we're going to get positive. So this is out. The green part, it is out because it will give us negative when you multiply them together. And then look at the orange part. This is graph of F, right? Be careful. This is the graph of F, the orange part. And then this is graph of G, the orange part. The graph of G is below 0, meaning it's negative. The graph of F here, it's above 0, meaning it's positive. So you see, when you take F, you multiply it by G. It's positive. It's positive multiplied by negative. It won't give us positive. So it is also out. Now we look at the purple part. The purple part, it's a graph of what? G. The graph of G here, it is negative. The graph of F here, it is also negative. So when I take the graph of F, I multiply it to the graph of G. Negative by negative at this point, at the purple part, what am I going to get? I'm going to get the positive. You get my point? So that means this is the correct solution. And then here it is going to be totally out because here G, it is positive, and then here F, it is negative. Therefore, negative by positive will give us negative. So this is also out. So our correct answer lies between the blue part and the purple part. So here we're going to say it's whereby X is between 45 degrees. And by the way, be careful. 6.3.2 not equals to 0. So we're not going to include anything. So everything is going to be excluded. We're going to use the inequality sign that will not include. So it's between negative 45 and negative 90 degrees, meaning it's less than, it's what? It is less than 45, but greater than 90 degrees. So the first solution here, we're going to say it is whereby X, that was long, hey? X, it is less than negative 45 degrees, but greater than 90 degrees. You see the inequality sign that I'm using? I'm not including anything here. And therefore, what is another solution? And another solution, it's going to be here between 135 degrees and 90 degrees here and there. Purple part. However, it is less than 135 degrees, but greater than what? Let me see. Again, greater than 90 degrees. Greater than 90 degrees. And then we answered the question. Ne? That's how we go about for 6.3.2. You see, take time to watch this video so that you can understand what I was saying if maybe you feel lost. Okay, take time to watch this video. If you really do not understand what I'm saying, it's simple, it's nice. You will see. If you get what I'm saying right here, you'll never go wrong on questions like this. Even on the functions, you will never go wrong. Because I know a lot of students, they struggle to questions like this. This is where they just pass and lose their marks, which I don't understand why. But take time to go through this if you really do not understand. So now we move to what? 6.3.2. Now look at 6.3.2. This one is a little bit tricky. No, it's not, because it's what we are looking at. They say use the graph, but the question is, where do we have 2 tan x? Our function there is tan x. minus 1. But we have 2x, 2 tan x. What? And then cos 2x. Okay, let's go check. We have negative 1 over 2 cos 2x. These are new graphs. No, they are not. Now, my advice, when you get to this question, let me show you what you need to do before you answer this question. Before you answer 6.3.3, what was the equation? It's 2 tan x, 2 tan of x is equals to, let me do this actually. It's not the part of the answer, just showing you what you need to do when you get here. We have what? 2 tan x is equals to what? Is equals to cos 2x. Oh, plus. Here we have plus sign, plus what? Forgot again. Cos 2x is equals to 2. Cos 2x is equals to 2. You know what is the plan here? The plan is to manipulate this equation so that I end up having tan x minus 1, negative 1 over 2 cos 2x. That's the plan. They won't give you this. Trust you me, if you manipulate this, you'll get there. So the first thing is I have to take cos to that side of the equation. You see, already. So I'm going to have negative cos 2x plus 2. You see? And therefore, what am I going to do? Already, remember, my aim is to have, oh, let me do this. I think I'm manipulating it wrong. I didn't do anything wrong. I was just manipulating it wrong. Remember, I want to have tan x minus 1. So how am I going to do this? Firstly, I'm going to take this to this side, right? I'm going to take cos that side. So I have 2 tan x. When I take this 2, it's going to be negative 2. And then I take this cos 2x, that side, it's going to be negative cos 2x. I'm sure you are seeing a way. Therefore, here I'm going to factorize. I'm going to take 2 outside of the bracket. I'm going to have tan x minus 1. And then here I'm going to have negative cos 2x. And then I divide both sides by 2. You see now, do you see now? We have that function, tan x minus 1, which is this. See? And therefore, look at that side. I'm going to have negative 1 over 2 cos 2x. You see? It's the same. So you divide by 2, it's negative 1 over 2 cos 2x. Happy. So now, this graph, tan x minus 1. So about that, tan x minus 1 is f of x. So basically, we are looking at f of x where is equals to this graph. Remember, it's g of x. So basically, we're looking for x, whereby f of x is equals to g of x, right? To answer this, the answer for this one, we are looking for this one. We are looking whereby this graph is equals to that graph. So where are they equal? At the intersection all the time. That's easy. They're equals to there. So you're just going to say your answer. It is whereby x is equals to 45 degrees. So that means it is whereby x is actually equals to 45 degrees. There is no any other intersection except this one. And then you answered 6.3.2. Okay, so do it like this. Okay, I think because it's 3 marks, just write it like this and show you end up here, and then your solution is x is equals to 45. So let's jump to 6.4 then. I'm taking time because because I'm referring to the basic as well. So 6.4, it says, if h of x is equals to sine x plus cos x divided by cos x, describe the vertical translation of h from f. Apparently, we have a new graph, this graph. This is a new graph, which is called graph of h. But the question is, how was this graph of h determined? To get the graph of h, we used the graph of f. How does the graph of f looks like? It looks like this. Graph of f looks like this. Wow. Okay. So the graph of f, it's tan x minus 1. The graph, so how can we talk about describe the vertical translation? How are we going to describe it? Because if we talk about we're looking at, remember from the basics, ne? I told that a a tan bx close bracket plus beta plus q. Remember, when you talk about the vertical translation, what are we looking at? Remember, this is a vertical translation, beta. It's a it's a horizontal translation. And then Q, it will be our vertical translation, which is up and down, right? Q. So in this case, when you have a look at graph of F, Q from the mother graph, remember, mother graph will be tan X. Immediately when we add -1, so the vertical translation is this graph from mother graph. This graph is shifted 1 unit downwards. That's the vertical translation from mother graph to F. So we want to know what is the translation from graph of F to H. Now we're not talking about the mother graph. We want to move from graph of F to H. You see, but the graph of it doesn't. So this is where you're gonna have. This is what you're gonna have to do to answer 6.4. You're gonna have to manipulate again that graph. Ne? You're gonna have to manipulate that graph of H. Graph of H, it actually looks like this. And go back, it's sine x plus cos x over cos x. It's sine x plus cos x divide by cos x. You don't see it as it is, but you can see it as you manipulate it. So when you manipulate this graph, right, so that we can see what was the vertical translation, let's use our basics of mathematics, where we're going to separate these two fractions. When we separate this, we're going to have sine x over cos x plus cos x over cos x. I just separated this big chunk fraction. And the what is sine over cos? Sine over cos is tan x. What is cos divided by cos? It's +1. So you see, this is how graph of h of x looks like. But remember, graph of f of x, it looks like this. It looks like this. See? It looks like this. Ugh, it looks like this, right? So recall that graph of f, it looks like this. So what we did here was to do what? Show you. What we did here, you see here it's -1, and then there's +1. Can you see that? What's the difference? What's the vertical? Remember, it's Q. It's a value of Q. The vertical, remember the basics. Q means vertical translation, right? So meaning we're gonna say this graph, it has shifted how many units? Go back to the Cartesian plane so that you can understand. If the graph for Q is -1, you see here it is. That means our graph will shift here. Will still be the same graph, but here will come here, right? This part will come here. Okay, let me try to draw it correctly as much as I can. Show you this graph. This -1 will come to +1, meaning shifting one, how many units? 1, 2, 2 units upwards. So this will come here, and then 45 degrees, it's 0. We're gonna shift 2 units, 1, 2. It will come here, 45. This will come there. This. So our graph will actually look like this. You see? Our graph will actually look like this to show that it is shifted 2 units upwards. See, from -1 to +1, 1, 2, we moved 2 units upwards. So that means, meaning this graph from -1 to +1, from -1 to +1, you see from F to H, from F to A. So what was the vertical translation? We're gonna say H at X moved or translated moved 1, sorry, 2 units upwards. Simple as that. You see, so you had to manipulate this so that you can see that graph of H is actually, it actually looks like this. That was the whole idea. Okay, so that was the whole idea. Right. And therefore, was it? Oh, here's the last question. They say determine the maximum value of. You see, we manipulate a lot here. You need to be very good at analyzing. Um, so they want us to determine the maximum value using graph of G. So apparently we have new graph, which is called graph of P. Okay? So we're gonna have a new graph to answer question number 6.5, I guess. See? Yep. Apparently we have a graph of P. How did we get the graph of P? We're gonna multiply graph of G by 4. That's how we can get the graph of P. We're gonna multiply graph of G, X by 4. So how is this graph actually going to look like? I'm gonna say 4 multiplied by graph of G. If I remember, it's negative 1 over 2 cos 2x. Confirm. Graph of G. Yeah. Negative 1 over 2 cos 2x. Negative 1 over 2. And therefore, let's multiply to get new graph, which is called graph of P of x. So this multiply by that, we're going to get negative 2 cos 2x. You see, this is a graph of P. Awesome. Right? This is a graph of P. So, what was the question? The question was, determine the maximum value of graph of P. Let's start. What's the maximum value of graph of G? Simple. What is the maximum value of graph of G? I said it before, if you remember. This is the minimum. The maximum is this one. By looking at the amplitude, right? It rises here. The maximum of G is going to be 1 over 2. If they say the minimum of G, negative 1 over 2. Minimum, max 1 over 2. So there, this question, they want the maximum of P. So P, it looks like this. Look at the amplitude. And again, what will be the maximum of P? It's going to be 2. It's going to be 2 of P of x. Okay, let me use the pen to answer this. We're going to say the maximum of P of x. It's going to be 2. Done. Does not matter how you have negative what. The maximum is the, according to our oscillation of our cosine function, according to this oscillation, we want the maximum, not the minimum. The minimum is below. The maximum is above. So it does not matter whether the graph starts with a negative or positive. You understand? So the maximum will be positive 2. So that's how we get to this final answer. And yeah, thank you guys. Hopefully if you don't understand, ask.